Thank you for being in attendance, and we're going to talk about Sierra-Olympia technologies and optical gas imaging. We're a small company, about 40 employees, and we specialize in both providing standard products and custom products as well. And everything that we do is internally funded. So we do have a lot of experience with mid-wave, long-wave, and short-wave infrared cameras, integrated dewar-cooler assemblies, electronics, firmware, and software. Also, we've done a lot of innovation with both fixed focal length lenses and continuous optical zoom lenses. And we have to be very conscientious about export of this technology, but everything that we do is what is referred to as non-ITAR and allows us to be able to sell to most places in the world. So our company is located in Hood River, Oregon. It's about 60 miles due east of Portland. And there we have our manufacturing, our corporate offices. We also have satellite offices where I'm located in Dallas, as well as in Atlanta. Our primary markets, unmanned vehicle imaging applications, persistent security and surveillance, and then what we're going to talk about today is industrial and optical gas imaging cameras. So we'll touch on the type of detector material that we use in these products, the resolution, lenses, firmware and software, and applications. So the first thing here is the camera that we introduced several years ago is innovative in the fact that we were the first company to employ what's called a hot mid-wave infrared detector. And before that, previously, these mid-wave detectors called indium antimonide detectors generally had to be cooled to cryogenic temperatures about 77 degrees Kelvin. Hot mid-wave means high operating temperature, so we didn't have to now cool that detector as cold as previously, so they operated about 150 Kelvin now. The benefit of that is that it basically reduces the load or the work on the cooler. It actually improves the reliability, gives it longer operating hours, but it also is very important because it allows you to reduce the size, weight, and the power. And so we went from much larger cameras that weighed several pounds. Now we're able to do that in a product that weighs a half a pound or about a little over 500 grams. The other thing that happened is for years and years, part of my background is I was originally involved in the first optical gas imaging camera that was developed from about 1999 to about 2003. And there we started off with a 320 by 240 resolution, or what is known as quarter VGA. And that's actually been the standard across almost 15, almost 20 years, until we introduced a VGA resolution, or 640 by 512. So the benefit there is you've got about 4 times as many pixels, and the benefit obviously of there is you're putting more pixels on target, so you're going to have higher resolution, easier to basically see these gas leaks, either smaller ones or from farther distances. The other thing that we did is we optimized the lens. We reduced the size and weight of it significantly. We also put special coatings on that lens so it lines up. On an OGI camera, you're putting a narrow bandpass cold filter in the cold section of the camera where it's sensitive to about 3.2 to 3.4 microns. And then essentially we did the same thing with the lens. So we're trying to get every photon that you can get into the camera to strike the detector and do that in an optimized way. And then the other thing is, obviously, when we introduced the product, we went through the testing to meet the OOOOa certification. So here's a short video. This is on a manned aircraft, and cameras integrated into in this particular case, it's a 5-axis stabilized gimbal. And this particular company is an aerial inspection company. I mentioned to you earlier about when we first started this industry, this gentleman named David Furry with a company called Leake Surveys out of Brownwood, Texas, was the very first person to really start using and helped us with the development of the cameras. So this is just integrated with a visible light camera, and then we have the OGI. You just saw that from the presentation before. So obviously the benefit of OGI, it allows you to see where the point source of the leak is emanating from. It's very visual, obviously, not only at doing the detection, but it's doing the visualization as well. These are a series of obviously well pads and also tank batteries, obviously with vents that are leaking, thief hatches, piping, flares as mentioned before. So all of these things are shown here. And we do also see it as the same thing as the earlier speaker, kind of a layered approach. You can use multiple technologies. One of the moves that we're now seeing, a lot of companies wanting to be able to integrate this with either sniffers or with TD loss lasers for doing the quantification. Here's another example of how the cameras are being used on fixed wing aerial platforms. Again, with gimbals, or some people have even done some fixed mounts. Obviously, for drones, because of the small size and weight, we've been able to integrate it onto a number of platforms. That's the DJI M300 or the M210 V2 it can be integrated with. There's another company called Evolve Dynamics. They have a multi-rotor as well. They have their gimbal is on the front of their UAV. Here's another video now showing that's the M210 right there. Again, the version 2. A short video here just showing you some of the capabilities. So that platform is very stable. It enables us to be able to use a mode in our product which is referred to as the gas enhancement mode. And that is then going to colorize the gas leak, so it makes it easier for the human eye to be able to differentiate that. You can adjust the sensitivity on that to make it such that depending on how still it is or how sensitive that you want to make it, makes it easier for, again, the operator to visualize the gas leaks. This also has digital zoom. You have a 1x, 2x, and 4x digital zoom capability, so you don't have to move any closer to the target or to the area of concern. The camera also has a 32 gigabyte digital storage capability. You can store video sequences or you can store still frames. For Quad OA requirements, typically you're going to record at least 10 seconds of video, and usually you're going to be recording a visible light image maybe with it as well. But again, with the resolution, it's almost like looking at a black and white picture. It's very clear, it's very sharp, it's very definitive, so you know exactly where that is. So the answer to that is generally yes. I mean, it's better to have where you have a greater delta T between the background and the gas. So the camera is doing two things. With that narrow bandpass filter, it looks at the absorption of the gas. But also, generally speaking, most of the industry uses about a 3 degrees centigrade delta T. It can be colder or it can be warmer, but you want that delta T. So if it's a sunny day or a partly sunny day, that's obviously better because you have more thermal loading, and the greater the delta T, again, the more visual it becomes. But it can be done 24 hours a day because, even at nighttime, that sort of thing, if you have a hot day or something like that, you still have the residual heat, and you can use it, again, 24 hours a day if you want to. So the other things you have to be careful with is wind. If you get into high winds, that sort of thing, it disperses the gas, pushes it. So usually, and especially with limitations on the aircraft, most people are not going to fly over like a 25 mile an hour, kind of a wind speed, for that case. And what will also happen, and if you haven't had much experience with it, if you have a cold background like snow or ice, that's going to be now dark. Basically, it's going to be cool. So now the gas is going to appear to be white. Everything that we've seen here, the background is warmer, so the gas appears to be dark or cool, right? And so it's just the opposite. And then all of the cameras, they have what's the ability to do is called invert polarity. So if you wanted to, for instance, the EPA makes all their operators generally use white for the gas no matter what. So they actually always try to make the background dark, and so that the image is consistent no matter where they're at, and so the gas always appears to be white. So here's another implementation, Spot. There's a company called MFE, and they've integrated the OGI camera onto Spot for doing a robotic type of route with the system. And also that can be taken off of that particular product, and it's converted and put into just a little handheld product with an Android phone interface to it. So it has a lot of versatile uses, and then from there you can actually remove the screen, and you can actually mount that onto, again, a drone platform. So kind of a multi-use. The other thing that's now starting to happen is we're working with a number of companies that are doing continuous monitoring and using edge computing and also using AI. And in this particular image, you see the camera mounted in an enclosure. It's a pressurized enclosure, so it's obviously weatherproof. In this particular case, it's a Class 1 Div 2 enclosure. And so it just learns the scene. It's on a pan and tilt, so it just does a 360-degree loop, basically, stops and stares at the various pieces of equipment they want to look at. And then as it learns it over time, then if there's something like in the bottom image, you start to see the gas leak. And then it has regions of interest that surround where the gas is going. It then highlights and colorizes it, much like we do in that gas enhancement mode. And then the final part of it, they're optically then quantifying that as well. So they're not using any other sensors at this point. They learn the scene, and then they're able to use the quantification so that they can set alarms. And from the alarms, those drive into either a SCADA system, a PLC, a digital control system, whatever they might have, and then that basically tells the operator, to investigate that scene further. The reality is that video is not even being shown in a control room. It only comes up when they need to look at it when it's indicated that there's a gas leak in the facility. With the way that the regulations appear to be headed towards, this continuous monitoring is going to be a very important thing. That is also why on this camera with the hot midwave infrared detector, as I mentioned, the increased reliability of the integrated doer cooler assembly is really important, because now you're doing this 24 hours a day, 7 days a week, 365 days a year. It's going to be a very important part of going forward with the way that the regulations appear to be headed. So again, we provide the electronics in this product. These are some of the capabilities. It uses different interfaces, H.264, analog video, also digital camera link as well. The onboard image processing are things like automatic gain and level control, CLAHI, local area processing, or gas enhancement mode. All of these things, again, to make it very easy on the operator, to make it just more of a point and shoot. There is capabilities with the encoder that we use also for adding target tracking, telemetry, NMEA, and GPS data. From just what we're seeing kind of in the industry, I think quantification being added to OGI is going to be a very, very important step. So you use the OGI camera, especially from an aerial platform, to basically detect and visualize. Once you know where the leak is, now you can fly over it. The laser is pointed straight down, so then it'll give you your quantification and your measurement. You could do the same thing with the SeekOps product. They use a sniffer, another way of doing it, but I think all of these things are important where we're combining the technologies to provide the best information that people can react to. The next step is going to be very important, just like the continuous monitoring. It's kind of an aspect of that, and that is, to me, combining it with the autonomous drones. Those that are going to be, again, just like Spot, but doing the aerial so that people will be able to fly that same route over and over every hour, multiple times a day, and then they look for that change detection, the automatic alarming capability, and I think that is going to be a very powerful medium, and you'll see a number of those products coming out here very shortly from different suppliers that we're providing our camera to. As I mentioned, on the fixed mounted continuous monitoring is the integration of data. Again, most everybody works with CMMS systems or and being able to provide this data into work order systems, your SAPs, your Oracles, your JD Edwards, Maximo, because that's going to actually drive the work. That becomes very important so that it gets completely integrated basically into the fabric and the operations of the companies. And I think not too far in the distant future, you're going to see more resolution out of the cameras. I think people have now got a real appetite for the change from going from quarter VGA to the 640 by 512, the VGA resolution. So the natural step is to go to HD. So in infrared, that'll be 1280 by 1024 or 1920 by 1200. And again, the whole idea is to get, just the ability to be able to find even smaller leaks if you needed to, or be able to do it from further distances depending on the optics that you use. Also see a lot of, I think, things will be happening more with lenses as well as we start to look at not only different fixed focal length lenses for longer range applications, but maybe you'll start to see things like continuous optical zoom lenses and things like that so you can vary your distances. And as I mentioned again, the use of video analytics and AI combined with the technology and or combining that with fixed PID sensors in the plants. So if there's an alarm that goes off there, then the cameras can salute a cue to where those leaks would be coming from and to be able to verify that, and then somebody could go out with a handheld camera if they needed to get much closer. And of course, what everybody wants in this industry is lower cost OGI cameras. And so we need everybody to buy a lot of them. And if they do that, we can reduce our cost as well and push all the individual component manufacturers and hopefully drive that cost down to make it more affordable, which also makes it better to integrate with all the other technologies that people want to integrate it with it. So we've been, in our industry, obviously, the OGI cameras have always been expensive, but we're trying to do everything possible to make it more affordable to all industry.